On Mod 4a, we are going to begin talking about rational expressions. First, just what is a rational expression? A rational expression is any expression that's written in fractional form. Remember that in order to be defined, the denominator of a rational expression cannot be zero. An excluded value of a rational expression is any value that would make the denominator of the expression be zero. For our first example, we are going to find all the excluded values for a rational expression. Since excluded values are the ones that would make the denominator equal zero, then we will set the denominator equal to zero and see where that occurs. Now we need to solve this little equation by subtracting 8, and we get 4w equals negative 8, and then divide by 4, we get w equals negative 2. This means that negative 2 is the excluded value for this rational expression. On our next example, we have the expression of v minus 1 over v squared minus 81. We do not care about the numerator. The numerator can be any kind of number, positive, negative, zero, it's fine. We only worry about the denominator. So we're going to set our denominator of v squared minus 81 equals 0. Then we need to recognize that this is a difference of squares. So this factors into v plus 9 times v minus 9 equals 0. Set each of those factors equal to 0. And then solve each one. We get v equals negative 9 and v equals positive 9. So this time we have two excluded values. On our next expression, we have y minus 5 over y squared minus 8y plus 15. We're going to set the denominator equal to 0. This denominator factors into y minus 5 times y minus 3 equals 0. Set each factor equal to 0, and we get y equals 5 and y equals 3 as our excluded values. On a problem like this, they're trying to make you doubt yourself and think that you have to worry about whether or not the numerator factors and setting it equal to 0. Yes, the numerator does factor, but we don't care. It can equal 0. All we care about is the denominator. So we're going to set x squared minus 36 equal to 0. That is a difference of squares, x plus 6 times x minus 6 equals 0. Set each factor equal to 0. And we get x equals negative 6 and x equals 6 as our excluded values. We must be able to simplify rational expressions. It makes them much easier to work with if we have to add or things like that. So in order to simplify a rational expression, we remove all the factors that simplify to equal 1. We are going to simplify the expression we are given. On the first one, it's already written in a factored form. And so what we need to note is that if we have 3w plus 7 over 3w plus 7, that does equal a 1. So we're going to take that out of there. We have a w minus 3 over itself. That equals 1. We're going to take that out of there. What we're left with at this point is 7 over 28. Both of those divide by 7, and we're going to get 1 over 4. Our second example to simplify is 36 times the quantity 2x minus 7 over 4 times the quantity x minus 4 times the quantity 2x minus 7. What we need to recognize here is that we have one pair of quantities that are exactly the same. So that quantity over itself equals a 1. So now we are left with 36 over 4 times x minus 4. 36 over 4 simplifies. So we got to think about both of those divide by 4. If I take 36 divided by 4, I get 9. 4 divided by 4 is 1. So the 1 can be written down, but it doesn't need to be written down. You are left with 9 over x minus 4. What's different about this next expression that we need to simplify is that the like quantities are not exactly over each other. But that's okay, as long as you have one in the numerator and one in the denominator, and they are exactly the same, they still equal 1 if you put them over each other. So we're going to just take those out. Now we are left with 5v plus 7 in the numerator and 20 times v minus 3 in the denominator. The two quantities do not simplify. You cannot simplify unless the quantities match exactly. These do not. But the plain numbers, 5 and 20, both divide by 5. So 5 divided by 5 is 1. If you wish, you can write it down, but you don't need to. And then on the bottom, 20 divided by 5 is 4 times the v minus 3. And that is your simplified version of that expression. Our next group of expressions to simplify are going to require that we factor them before we do the simplification. So looking at this first one of 7w plus 56 over 4w squared plus 32w, we have to check to see what we can do in both the numerator and the denominator to factor it. The numerator, we can pull a 7 out of each term. Take out a 7. 7w divided by 7 leaves us with w, plus 56 divided by 7 leaves us with 8. Over. Now, looking at the two terms in the bottom, they have a 4 and a w in common, so we're going to factor that out. If I take 4w squared divided by 4w, I'm left with w. If I take 32w divided by 4, I'm left with plus 8. Well, now I have quantity w plus 8 over itself. That equals 1. So I can simplify and take that out. And what's left is 7 over 4w. Check to see, is there anything that I can take out that goes into both 4 and 7? There is not. So this is your final answer on this expression. On our second example, if we look at that numerator of 2x squared minus 10x, what's a common factor? It's 2x. We're going to pull out 2x. 2x squared divided by 2x leaves us with x. Negative 10x divided by 2x leaves us with negative 5. In the denominator, what's in common for 7x squared minus 35x? 7x is in common. 7x squared divided by 7x leaves us with x. Negative 35x divided by 7x leaves us with negative 5. So now we have factors in the numerator of 2 times x times the quantity x minus 5. In the denominator, we have factors of 7 times x times the quantity x minus 5. The obvious things are the quantity x minus 5 over itself. That equals 1. We're going to take it out. What you may not also recognize is that we have a factor of x over x. That too equals 1. We take it out. So we simplify down to be just the two numbers of 2 over 7. On C, our numerator of y minus 6 has nothing that we can factor out. It is as simplified as it gets. we're going to leave the numerator alone and it will just stay y minus 6. The denominator is a difference of squares and is going to factor into y plus 6 times y minus 6. Now we do have a matching quantity of y minus 6 over y minus 6. So that is a 1. When the entire numerator has simplified with something in the denominator, you still have to hold the place of the numerator. What's left up there, if you take y minus 6 divided by y minus 6, what's left is a 1 over, and then we had the quantity of y plus 6 left in the denominator. The numerator cannot just disappear. It still has to be there somewhere. On D, we have a numerator that factors. X squared plus 7x plus 10 factors into x plus 2 times x plus 5. We have a denominator that does not simplify. It's simply the quantity of x plus 2. But we do have a matching quantity here of x plus 2 over itself. So that equals the 1. And we are now left with x plus 5 in our numerator. We simplified the entire denominator. We took x plus 2 divided by x plus 2, which does equal a 1. You can put in a 1 for a denominator. It is not necessary, however, to show 1 as a denominator, so you could just write this one as x plus 5. On our next example, we have a numerator of w squared plus 2w minus 24, and that factors into the quantity of w plus 6 times the quantity w minus 4. On the denominator, you need to notice that 2 goes into both terms. We're going to factor out a 2 and have w squared minus 36. But that quantity that's left inside is a difference of squares. So we need to continue factoring that. The numerator stays as it is, w plus 6 times w minus 4. The denominator will factor into 2 times w plus 6 times w minus 6. Now we have a matching quantity of w plus 6 over itself. That's a 1. We're going to take it out. And then we would be left with the quantity of w minus 4 over 2 times the quantity w minus 6. On the next example, our numerator has a common factor of 2. We need to pull that out first. If we take 2 out of each term, we will have y squared plus 4y minus 5 left inside over y squared plus y minus 2 factors into y plus 2 times y minus 1. Check your numerator. Does it factor further? And it does. Keep that 2 on the front. And then the rest factors into y plus 5 times y minus 1. The denominator has already been factored into y plus 2 times y minus 1. We have matching quantities of y minus 1 over itself. We're going to take that out as a 1. What's left then is 2 times the quantity y plus 5 over the quantity y plus 2. In general, remember that when you are multiplying two fractions, you multiply straight across. But when we have expressions like these, and they might simplify, it frequently is much, much easier to simplify before you start multiplying. For example, on this problem where we have 5 over 4x plus 24, I can factor 4 out of that denominator. So I'm going to rewrite the denominator as 4 times x minus 6. This is times, on the second fraction where we have 4x minus 48 in the numerator, we can factor out a 4 there also, and we will get x minus 12 left inside, and then that's over a denominator of 9. In looking at this, let's see, do we have any factors that are exactly the same that would cancel out as a 1? We have a 4 in the numerator and a 4 in the denominator. 4 over 4 equals 1. Nothing else is exactly the same and can be simplified as a 1. So our final answer would be 5 times the quantity x minus 12 over 9 times the quantity x minus 6. For our next example, when we look at the first fraction, x minus 2 does not simplify, so we're going to leave the numerator of the first fraction alone. The denominator will factor into 3 times the quantity x plus 3. Moving to the second fraction, the numerator, we can factor out a 9, and that would leave x plus 3 inside. In the denominator, we can factor out a 4, and that would leave a quantity of x minus 2. So now let's look to see if we have anything that would be exactly the same and could be simplified as a 1. We have an x plus 3 in the numerator and the denominator. X plus 3 over x plus 3 is 1. We have an x minus 2 in the numerator and the denominator. That over itself equals 1. This now leaves us with 9 over 12, 2 into 3 times the 4. But that simplifies, divide them both by 3, to 3 over 4. On the next example, looking at the first fraction, our numerator is 4x plus 12. Well, that has a common factor of 4. If we pull that out, we'll be left with x plus 3. The denominator is x squared minus x minus 6, but that factors into x minus 3 times x plus 2. For the second fraction, we have x squared minus 5x plus 6 in the numerator, which factors into x minus 3 times x minus 2 over the quantity of x plus 3. Now we look for items that are in both the numerator and the denominator that we can simplify as a 1. We have an x minus 3 in both the numerator and the denominator. We have an x plus 3 in both the numerator and the denominator. If we take those 1's out, we will now be left with 4 times the quantity x minus 2 over the quantity of x plus 2. Remember, the rule for dividing fractions is that you multiply the first fraction by the reciprocal of the dividend, which is what we are dividing by. For our first example, we have 7 over 2x minus 10 divided by 5 over 6x minus 30. So our dividend is the second fraction. The first fraction we leave as is, 7 over 2x minus 10. We now change to multiplication and then flip over the second fraction. So it becomes 6x minus 30 over 5. Now we just go back to what we were doing on our previous examples. Look for common factors and simplify. Our first fraction, the 7, doesn't simplify, but in the denominator we can pull out a 2 and have x minus 5 times. On the second fraction, the numerator, we could pull out a 6 and have x minus 5 over the denominator of 5. Do we have any like factors, numerator and denominator, that we can simplify as a 1? We have x minus 5 and x minus 5 in both. So now we have the 7 times 6, which is 42, over 2 times 5, which is 10. Those both divide by 2, we get 21 over 5. On the next example, the first fraction is going to stay the same. We are going to change to multiplication and flip over the second fraction. So it will become 3x minus 3 over x minus 2. In looking at that first fraction, we're going to have all kinds of factoring happening here. The numerator of x squared minus 5x plus 6 factors into x minus 3 times x minus 2. The denominator factors into x plus 2 times x minus 1. On the second fraction, when you have 3x minus 3 in the numerator, you're going to pull out a 3, leaving x minus 1 inside. The denominator does not factor. So now we're going to look for common factors in the numerator and denominator that we can take out as our 1s. We have an x minus 2 in both places. We have an x minus 1 in both places. Now this leaves us with a simplified answer of 3 times the quantity x minus 3 over our quantity of x plus 2.